Next up, we have Megdud, who is the Director of Cloud Engineering Team at PayPal, and his talk is titled, A Story of Cultural Change, PayPal's 2-year journey to 150,000 containers with Docker. So please help me welcome Megdud.
Hi, my name is Megdud. I manage the container platform team at PayPal. And today we are going to take you through our 2-year journey at PayPal, introducing containers for existing applications in our large enterprise. And the challenges we faced, the key takeaways, the strategy, the pitches to our executives. So we'll just walk you through that entire experience. So with that, we start with what PayPal is. I hope I'm not going to offend anybody when I say that in general, people love money. And more importantly, they care about their transactions not failing when they are interacting. And even more important, the accounts managing the money is secure. And that's where PayPal is. And on top of that, there are a lot of small businesses, mom and pop shop, who only take PayPal as their form of payment. So if we are not available enough or we have issues, they lose business. And these days we have our latest mission has been to really go in the markets to serve the financial underserved. And so those are large goals. And in Q2, this was our numbers in Q2. I think our Q3 earnings is coming in a week. We, for the first time, crossed processing $100 billion in one single quarter. And we had $3 billion of revenue, 200 international markets, and over 210 million active accounts. So this is kind of the backdrop. And when we decided to do and introduce containers, we did not want to do any side case, some new greenfield. We wanted to do for the core business. So our margin of error in our execution was like virtually nil. So with that, we had to set some ground rules before we started this project 2 years back. And I'm going to take you through that journey. So if you're planning a container journey in 2017, it's not easy. Because very soon you're going to see the 4 arrows I've drawn. Yeah, you have to containerize for sure. On the left, you have like container as a service platform. So the Kubernetes and the swarms and mesos and nomads of the world. You have serverless paradigm on the right. And then on the bottom, you have microservices. Now, in reality, all of them stand out on their own benefits. And they complement each other very well. But if you are looking at like articles or things like that, often all of them are jumbled up together. And they don't have to be all implemented at the same time, especially in the context of a large or mid organization, to reap the benefits. You can phase them out. And that's what we are going to share with you today. So in essence, benefits of pure containerization is different from orchestration CaaS platform, what benefits that brings, and definitely different from microservices. And that's kind of the key takeaway I wanted to share here. So this is our kind of journey timeline. PayPal spun out of eBay around mid-2015. That's when the team kind of got formed. Late 2015, we engaged with Docker Inc. And I will share you the story and all the things behind that. And we started our integration of Docker in our PDLC and software development lifecycle. April 2016, kind of 18 months from now, was the first time we launched our container in QA and prod. Late 2016, we started investing on our container platform strategy, the full-blown CaaS. This year, around mid, we started rolling out tools on Docker on Mac and Docker on Windows, and I will share what those were. And we are now in the Q3, Q4 period where we have entered Q4. So we are launching apps for the first time in our container platform in QA. And next year is our production target. And I'm going to walk you through all the phases of those today. So as I said, we had to set some Cardinal Rules before we started the project. So the first one was stay invisible to developers at onset. And this might sound like an anti-pattern because Docker became popular for the developer revolution and the productivity and everything it brings. Yet we felt at the onset, in a large organization like ours, we have like almost like 3,000 engineers all around the world. They are busy like developing and scaling our payment platform, building the experiences, and to just suddenly ask them to become Docker experts and write the best, implement the best practices, we did not think that was the right thing to do. And we wanted to unveil that at the right time, but not at the beginning. Second, target existing applications first. Well, I guess that was a name we've heard today. It's called MTA. Back then, there was no team like name around that. So we definitely wanted to go for our core business applications because we felt that if we do a greenfield or a side use case, we can't prove to the company the return on investment. So we wanted to have a large mass of applications containerized to really show the benefits of containerization. So that was our like target from day one, not new apps or a particular use case. Go for your existing apps. And we had 15 years plus worth of applications. The third rule was do not fragment environments. Often we heard that, okay, we are doing Docker just for QA environment or just for particular this use case. Means enterprises are fragmented enough. And whether the drift is planned or unplanned, it has a lot of like headache and a lot of wasted cycles. So we said that if we are going to go in QA, we are going to go in production right away if the QA is fine. And that was kind of our goal there. Do not promise miracles at start. Means, again, if you're reading articles today, there are a lot of benefits promised and a lot of things. But as we started to kind of do the program at the beginning, we said we are not going to overpromise. As we do the phased approach, we are going to have increased benefits. And so we never wanted to be in a situation that people think we are bluffing. And last but not the least was the core dedicated team to lead. We debated about this, and we felt right at the beginning there needs to be a centralized team who can drive this. Because we felt that the ecosystem partners, the different teams that needed to understand Docker and deliver the integrations all throughout PayPal, it would take a lot of time to make them experts. Instead, we formed a team, and we will share what were the dynamics of the team, how we felt like what was the right composition of that team. So with that, we will go into the phase one, which is like containerizing apps as is, or MTA, you can say, in today's world. So the goal for this phase was we wanted to introduce containers as a packaging format. Think of your tar, you're moving to RPM, now you're moving to an image. And move to your container runtime without like disrupting the ecosystem at all, like very little touch points. And aiming to containerize 100% of the production workload. So that was the kind of the key goal. Not running a CAS platform, not like efficiency gains, not any other things. Just pure packaging format. And let's try to introduce that in our SDLC. So that was the mission statement. So if with that mission statement, we said, okay, what the team composition is going to look like. And I want to share what are the key characteristics of the teams were. So we debated about, should the team be expert at Docker, but have no tribal knowledge of that 15 years worth of software getting written and the gory details of C++ versus Node versus Python versus Java and things like that. And we have 3 generations of Java, 4 generations of C++. And if you are going to tackle this head on, we said, like, let's find those old-time engineers sitting in different pockets. Let's see if they're interested and willing to take on the challenge. Because though they know all those details, and on top of that, we understood that if the ecosystem partners are not going to be there to help us, we're going to have to make changes in other people's code base. And if these guys are old-timers, respected and trusted, chances of those things moving faster is much easier and less friction there. And we wanted to like form a startup by itself, meaning we are going to introduce a new container OS for the first time in PayPal. It will be different than the existing OS. Puppet modules need to be changed, framework scripts. There was the whole full stack, and we wanted the team to support that. And last but not the least, the team had to be Docker experts to know how to implement the best practices. Then we thought about, okay, the dedicated migration engineer. So this was different than the core team. This was the person who was actually sitting with the customers, which are our internal teams, our development teams, and migrating their applications in QA, in production. The mindset of this engineer was completely different. They are focused on 100% execution, excellent communication skills, being patient with customer queries, and things like that. And then prep time on the right side. So we've spent sufficient time with Docker before we even started our project. We want to be entirely confident with all the nuances and the best practices and not ramp up ourselves as we're doing the project. So we wanted to be very confident of that. At the same time, late in 2015, we said if we are going to go in production, we might be experts in Docker user space and understand some of the technical details, and which is very much important. I can cover that later. We are not going to patch Docker engine. And if in the middle of the night we find a bug and that's impacting payments, we are in a very bad situation. So we reached out to Docker Inc. at that time and formed a partnership. And it was the idea, and it has served us wonderfully well. And the idea at that time was we can't keep up with open source and do that fast iteration with the versions coming out. So we would have to backport important fixes to the older versions we are running. And that exactly happened, I think, quite many times there. So with that, what was the kind of the mindset of phase one, or the containerizing apps as is? The first was, do not hide the migration. So yes, it was black box to the developers. We did not want developers to really understand what Docker is other than like, oh, my packaging format is changing and it's getting bootstrapped in a different way. But do not hide the migration that when we were migrating that application, we engaged with the customers very heavily in every step of the process. I think I covered that a while back, is work on full stack. We expected this core team to really work on everything. So what is our container OS, what kernel version we are going to run, all the choices to up the stack all the way, that how the UI is going to change, or what are the framework scripts going to change. So what is our Docker file going to look like? What are the Docker Compose file going to look like? So basically, the entire thing. Recognize you may have one shot. On the left side there means we have dealt with different projects dealing with the legacy applications. And oftentimes, a lot of those projects failed, even after 6 months or 1 year later. It was too difficult to navigate. We couldn't deliver the projects on time, or the value was really not realized. So very early on, we realized we are going to tackle legacy, and there's a lot of taboo around that, so we have to prove it wrong. Minimal ecosystem changes. So I'll give an example on that one. So before we containerized, our applications were running one application in a single VM. There are some system agents running, but pretty much one application. So we felt that if that application is containerized and running in that same old VM, of course, the container OS is different, but it's running host networking. So all the monitoring software, alerting software, the assumptions that if the CPU is running hot, most likely it's coming from that application. There are a lot of different things that were built in over time. None of that needs to change. They don't need to know that it's running inside a container. And so the log files were dropped in a certain location in the host, and some mining tool will grab it, some UI tool will grab it. None of that really needed to know that, hey, it's host mounted inside a container and it was dropping that. So again, minimal ecosystem changes. The idea was, let's change the workflow and just put Docker in, but kind of relatively have minimal touch points. 100% laser focused on as-is migration. The minute we started the project, a lot of concerns started coming in. It was like, okay, you're doing containers, why not move into like bare metals? Why not like start with a cluster manager and pack multiple containers? And why not let's start refactoring and go to microservices? With our first phase 1 mission, all of them were like orthogonal, like separation of concerns. We said, yeah, all of them we can do, but not at this point of time, and we can start different projects on those later. And of course, like there are every week some new capability is getting introduced, and sometimes we were second guessing ourselves, but we have to show confidence on our roadmap and just execute that. And I think fast output is very essential, like I think our last speaker was mentioning. Guilty until proven innocent. This is my favorite one. As developers and engineers, when we like deliver our piece of code and someone says that there's a bug in there, sometimes you're pretty confident there's no bug, and why don't you prove it, and then only I'm going to look. In this case, the developers were trusting us with a black box migration, right? The idea is they're not making any code changes. We are containerizing it and running it. And if there are issues, they are not experts to really debug. And so we went with that mindset that, hey, we will declare ourselves guilty and work with the developers for all the root cause analysis, and then we'll say we are innocent, it really is. And there are some funny incidents around that. I think there was a team one time, like morning, they said, hey, you guys containerized us in production, and we are seeing like SLAs bad, perceived instability and things like that. And we went back and checked that, yeah, we did containerize you in QA, but you are not in production yet. That was the easy one. There has been like standard false positives, which we kind of anticipated that code bugs would be introduced at the same time we are migrating into containers and rolling in production, and that happens a lot. And we have to just sit with the customers and show it's really your code, it's nothing to do with Docker. And there were some use cases where we were also at guilty, but that was kind of the mindset there. Spread the knowledge. I think, yes, initially your ecosystem partners, the different teams don't know about Docker, but the idea is to sustain this program for a long time and really to scale the program, they need to ramp up as well. So you are the evangelist, you are the best trainers, so go ahead and start doing that kind of work. So that's what we kind of did. Last but not least was expect pushback. Even with like saying to the customers that is seamless, all you need to do is run regression tests to see like nothing is broken. Sometimes developers said like, oh, we don't even have the time to do that. And in those cases, we kind of went and said that, okay, we are going to learn your application and we are going to run your test suites and kind of prove that everything is good. So persistent there. So rollout strategy. Rollout strategy here is, yes, again, like black box to the developers, but really not black box to your production operators and your L1 support engineers. Because when issues come at site, they are the first responders, and they need to like know the basic triaging commands. And standard operating procedures. I think I covered this one, communicate. When we started reaching out to the developers and saying, we want to migrate your application, we gave them exact steps of like how we're going to migrate QA, how in phases and chunks we are going to migrate the production, what are the benefits, everything. And we opened Slack channels with them, and so to kind of make sure they could ping us anytime they had a question. And of course, you have to find champions, critical for word of mouth and patient initially on the rough edges there. And the champions are always there. So introduce container format into PDLC. This was the execution strategy and the core benefits of the phase 1. So I keep saying black box. Black box pretty much to developers means that they don't have to understand Docker files. They don't have to write Docker files. In our case, we used Compose. They don't have to write Compose files. So it was really, in that sense, a black box. But we had to generate those things in our life cycle. So our Jenkins build said, okay, you are a Java app, and I know what the Docker file is going to be, what is the Compose file is going to be, and it was a template, and it got generated, things like that. I'm not covering the technical details in this talk. It was covered in a lightning talk in the DockerCon US, and I can go over it after the talk. But this is more about the process and the strategy there. And we were really putting the Docker infrastructure in place, meaning we were rolling out the Docker Trusted Registry in all our production and QA. We were hardening our container OS. So those are the things we were like laying the foundation on. This was a very important point for us, decoupling deploy platform from framework stack. So our deployment system, the proprietary system which we ran on top of our VMs, actually understood that you are deploying a Java app or a Node app or a Python app. And there was a tight coupling between the framework scripts, bootstrapping that application, and the deployment script. So oftentimes, an issue came up. There was always this friction between the platform team and the framework teams saying that, okay, who owns this, and things like that. So what we started saying that with containers, we are going to have really clean primitives. We're going to start, stops, and signals to the containers. We don't care anymore how the application workload starts inside the container or whether you're a Java or not. So it drastically simplified our proprietary deployment system and had a very clean separation of concern. Modernizing OS and kernel from decade-old versions. So our OS was almost 10 years old. Of course, then the kernel is 10 years old, or even actually more in this case. And what happened was, without writing a single line of code, because they moved into container OS with a brand new kernel, developers the applications started to enjoy that. And we measured that the throughput of some of the applications basically increased anywhere from 10 to 20 to 25% without a single line of code change. So inside the container, they were still running with the base image, which was 10 years old. But of course, all the system calls were going through the modern kernel, and that's how they kind of got the performance benefit. And this phase really paves the way for the next chapter and developer-centric tools and the full-blown container system. So this was our kind of report card. In 18 months since April when we launched, we are like somewhere between 700 to 900 applications completely Dockerized and running in production. And when we started Dockerizing a particular stack or migrating them, we made sure a new application created in the stack is going to be Docker from day one. So we kind of stopped that leak, and we have a deterministic set we go after for that migration. So out of the 700 plus or 800 is some of them are new, and of course a bulk of them are migrated. So we are running more than 45,000 container VM hosts in production, and depending on the stack, it is running 3 to 5 containers, application container, sidecar container, some system containers. So that's how the 150,000 math comes into picture in production. And most importantly of all, if you are going to www.paypal.com, the homepage is served to Docker. If you are logging in, if you are doing payment at site, Docker is in every critical workflow. We are not 100% migrated, all the applications, but we have taken on all those critical flows with our use case in phase 1. Phase 2. Phase 2 is why we wanted to really do Docker and introduce this to our developers, right? So this is the time we wanted to open no longer make it a black box, unveil Docker to the developers. By this time, the developers understand that their applications are running in Docker containers, some training, some education, and we felt that this is the time when we start introducing the true value of Docker and like open up DevOps into brand new areas. So expose Docker to developers, no longer a black box, which I talked about, and unlock this technology. So how we wanted to do that? So we started developing tools on top of Docker for Mac, and we are really starting to do on Docker for Windows as well with the Windows 10 Pro. And the tool was all about building, deploying, and debugging your QA applications right out of your laptop. So you don't have to leave laptop. It's a full development environment. So for your Mac, you use build containers to build your applications, deploy that, and the full workflow. And I can share some of the results there. And the idea is if there's a mass adoption on that one, you also save on your cloud assets. And there was significant reduction in the time to like iterate with your few lines of code change and test in a QA environment. Extend DevOps platform to greenfield apps. So now we started saying that previously our existing deployment platform, as I said, really had the knowledge of your Java or your Python or things like that. Once we did that decoupling in phase 1, we started saying that, okay, we are open for Go, PHP, and there were use cases like that. And they couldn't ever come into our automation platform. They used to file tickets because it was not a standard stack and things like that. Suddenly, this opened the door to all those one-off use cases. And especially a lot of internal tools were getting written in a lot of newer languages and stacks. So, and in production, there was limited few as well. So we opened the DevOps automation to them as well. Enables new ecosystem apps and tooling. This was more about, remember the base image which was running inside the container? It was still 10 years old. A lot of the new modern application stacks wanted modern user space libraries. And we said, like, okay, let's start upgrading those base images one stack at a time for people who really need it. And that unlocked like a whole set of new tools for those stacks. And last but not the least is we wanted to see in phase 2 that in phase 1, since we had laid down all the foundations of running Docker, to have independent use cases where we don't even know that those use cases are getting built. And that exactly happened. And I will share in the next slide the progress report on that one. So the first one, run Q environment locally. What we measured, it was saving almost 50% of the cycle time to kind of build, ship, and deploy and test your kind of application there. And really, like, that's the point where the developers started having an aha moment, that this was not like a step up and certain new features getting introduced. This was something they could never do before. Like, our Q environment needs Python, C++, your actual application, everything to run. And to just run at the click of like a CLI tool and everything is getting bootstrapped in their Mac, and that was like amazing for them. And then the second point is, as I mentioned, we were like opening up doors to kind of new custom stacks. Modernization of the OS image. So we upgraded our entire Node.js application suite to move into this new modern base image. And that literally happened from the next build. Your Docker file moved into a new base image. How cool is that? And I can give you one example. Right around 2006 or 2007, 10 years back, or it's actually more than that a little bit, it took PayPal 1 whole year to upgrade the OS, because we had to recompile every single tool sets and applications that ran in those boxes. Even if the goal was to like really upgrade one, we had to like support the entire tool chain. This time around, we could target what we really wanted. So that Node.js running with that modern base image has sidecar and system agents still running with the old base image. So we could really target that. And then that's the power, right? And we started seeing healthy growth of like other use cases. Our data platform, our risk platforms, they started like innovating their own Docker use cases without us getting involved at all. So phase 3 is the last phase, and this is really about container orchestration, full-blown container platform, your rich networking, storage, all the things which you really wanted to do at the onset, but we were not provoked to do that. And this is our multi-cloud strategy, the common abstraction, as you heard in the keynote as well. As we are moving into multi-clouds, this is the common layer. We don't want to build infrastructure every time we are going to new clouds. We want multiple experiences supported through one consistent platform. So now we started, let's say, the operations goals we have taken. Now we started taking efficiency goals, because we never took efficiency goals in the phase 1, because your VM still stays. We are not really saving anything. Now we have taken, and as we are moving into QA, we are seeing 50% reduction in the vCPU. We are bin packing and really running things tightly. In production, we are conservative. We are taking a 25% goal there. Security is a big thing for us. We want to patch our site as fast as often. With a cluster manager, it's well known. It can be drained. The containers move into good hosts. You patch them and bring them back. Elimination of VM provisioning. So we're still running in virtualized infrastructure, but this is our cluster manager. They can shrink up, they can flex up, flex down, but it's like I need 5 instances of the application more. I don't need to spin 5 VM anymore. So that's there. Bottom there, major availability improvements. This is again like nothing new, common to entire cluster managers is we are moving to a dynamic placement model from static pool partitioning, right? So those are common points. Anything can really run anywhere in the data center. But last, I think I will jump to this point 6, is all it is about one consistent platform. We, like 15 years has introduced a lot of different tool chains doing almost the same thing. but it is a maintenance hassle. So we really want to give to the operations that this is one tool chain which is running, and all the tools which they use kind of get standardized. On the developer side, the benefits, again, it comes to the consistent platform side. Today, they actually get exposed when they are deploying a C++ app versus a Node.js versus a Java. They have to go through different tool sets. What we want to say that stop doing that. Doesn't matter QA, production, multi-cloud, you always interact with the same tool set. And really, we want to have different experiences maybe, but not build the infrastructure every time there's a new experience. Reliability and resiliency. Again, any CAS platform moves into a declarative model rather than an imperative model. So the system is trying to always make sure your 100 instances or 1,000 instances of your app is always running. You don't need a separate kind of a fault-tolerant system there. So these are, again, like CAS benefits, which we are kind of pitching for our phase 3. And deployment performance, it goes through a modern scheduler. There can be predictable auto rollback inside, and we deploy all across the world when our applications roll out. And in our current existing world, it does take like hours to do that. And we have taken a goal to do it less than 1 hour. And again, like elimination of VM provisioning is kind of good for developers. They don't even have to understand that. So to summarize, this is what we started on the left, phase 1, saying just let's containerize applications. And what we wanted was let's build that mass and let's build that muscle that if I have 500 applications or 700 applications, the minute we move to phase 2 and introduce these development tools, hundreds of developers are going to leverage that. Because it's not about, so we did not want to build those tools or build a CAS platform, have those investments, and then say, oops, we are now going to start containerizing your first application. We wanted to do the reverse way of just make it stupid simple in phase 1, and then as we move into these later phases, we have a lot of applications to work with to showcase the benefit. So phase 3 is CAS, and now what's happening right now is, as we are migrating an application or the next new application, it is getting Dockerized. From day 1, it has the Docker for Mac or Docker for Windows, the tooling which we have built, and probably in next DockerCon we'll have a talk on that. And then it's moving directly into the CAS platform, skipping the entire proprietary deployment system. So it is, with the CAS, you are really about deprecating your 15 years worth of tool sets. And all 3 are now happening for every new application or migrated application coming to the picture. So I think that's probably was the last slide, and we can do some questions. So I have like 3 minutes. Yeah. Oh, for the CAS? We will share that probably in the next DockerCon. We have kept it open to the idea that you could run Kubernetes in one AZ and Swarm in the next AZ, and today's announcement makes it easier, or Mesos in the third AZ, because we felt our deployment orchestration is very, very complex, and we felt every cluster managers have very common primitives, and we wanted to do the orchestration ourselves and think cluster managers as plugins. So we have taken that approach. So we are going with that approach. We'll share it next time. Yep. Good.
With a bigger organization like PayPal taking 2 years to do this, and something like Docker being something that evolves all the time, how has it been from the start to the beginning to the end of following along with the versions of Docker? Are you running, for instance, the newest version on your platform in your build tools of Docker now?
Newest versions of Docker version, you're saying? Yeah, so right now, for example, we are still running 112 in production. And in QA, we just moved into 117.3, which is the newest EE chain. And so we are a little behind, and we are usually cautious. We don't upgrade before 6 months that has been out. So we want some bugs to be fixed before we take on. And we do have found issues at our scale. But that's where the Docker engagement has really been very helpful. They have come and fixed those bugs. And every one of them landed in open source. Yeah, good.
When you started this transformation,
Yeah.
and how long it takes between phases?
So phase one, as I go to the initial timeline, phase one, we started April 2016. Development of phase one started late 2015, right? And then the CAS platform, which we are building, was started like late last year. The tool sets development started beginning of 2017, the Docker for Mac, and we delivered like middle of 2017. So of course, the development starts a little early than the actual launch, and that's how we are managing that. Yeah, go ahead.
Has there been anything you haven't been able to Dockerize, and how have you worked around that?
I can't hear you. Yeah, sure.
Is there anything you haven't been able to Dockerize, and if so, how have you been able to get around it?
Actually, that was a common concern at the beginning that there might be something we will not be able to Dockerize. So far, we have been able to Dockerize everything. So that has not been a challenge. Yep. Yeah. Yeah.
Seems like you're averaging 3 to 5 containers per host.
Yeah.
Is there a reason behind it, or is there a strategy?
Yeah. So, for example, for our Node.js stack, Node.js has an Nginx bundle into it to do the SSL termination. Because for Node, it's still like costly to do that in Node itself. So for us, it was 2 containers: Nginx in a different container, Node running in a different container. We have, and when we moved into a container host, our idea was, let's try to containerize our system agent. So our logging monitor, a singleton daemon running in that host, that is containerized. So overall, the application can have 1 or 2 sidecars, maybe Nginx or something else. And there are a couple of like singleton daemon running in containers in every host. So that's how the 3 or 5 comes in. So it's not like multiple applications. Yeah. Okay, I think that's good. Okay. Oh, thank you.